In this lesson, we'll be learning about integer exponents and order of operation. First, for integer exponents, we need to learn that exponents are just repeated multiplication. For example, 5 cubed means 5 times 5 times 5, or 5 multiplied by itself 3 times. So we're repeating multiply by 5 to the exponent, whatever the number of the exponent is, that's how many times you do it. So 5 times 5 times 5 is 125. Now for this expression 5 cubed, the 5 is called the base, and that's the number that you repeatedly multiply. And the 3 is called the exponent. And that determines how many times you actually multiply the base. So the 5, we said, is the base. The 3 up here is the exponent. And the whole thing is called a power. Although sometimes some books or some people use the word 3, the exponent 3 as a power. Technically, the 3 is the exponent. The whole thing is technically the power. So we're going to simplify the following. 4 cubed means 4 times 4 times 4. And 4 times 4 times 4 is 64. For the next problem, we have 2 to the 5th. 2 to the 5th means 2 times itself 5 times. So this is a lot of multiplication, so let's just do a couple at a time. 2 times 2 is 4. 2 times 2 is 4, and then we still have another multiplied by 2. 4 times 4 is 16, and that all multiplies out to 32. Now, you don't have to necessarily show all that work, but you need to get 32. Negative 2/3 squared means negative 2/3 times itself, negative 2/3. Notice that if the negative's on the inside, we just repeat that negative because it belongs with the 2/3 twice. Okay, so negative 2 times negative 2, multiplying fractions, we just multiply the top and get 4. Multiply the bottom, 3 times 3 and get 9. 4/9 can't reduce, and so we are done on that one. 6/5 cubed means 6/5 multiplied by itself 3 times. Again, multiplying fractions is not that difficult. So 6 times 6 is 36. 5 times 5 is 25. That's for the first two fractions. And we need to do it again, times 6/5. That's going to get me 216 on the top and then 125 on the bottom. There's no like terms and these can't reduce, so I'm done for that part. Now, next I have a couple of problems with negatives on the outside, negatives on the inside. Notice the next two look kind of similar. Negative 2 to the 4th and the quantity of negative 2 all raised to the 4th. So they mean different things. So if you have a negative out in front but not in a parentheses, that means this 4 only applies to the 2. It's almost as if the negative's out in front and then you have 2 to the 4th. Because the 4 really only applies to the 2, not the negative. Now that's not the same thing as the next problem. The next problem has the 4 actually applying to the parentheses, and everything in the parentheses gets to be included. So the first one is negative, or like almost like a negative 1, times 2 times 2 times 2 times 2. You have 4 2's with a negative out in front. Whereas the second one really means negative 2 times itself, negative 2 times itself, negative 2, negative 2, 4 times. These are very different answers. I actually like the first one better. I think it's a little easier because the answer is just going to be negative. One negative times a bunch of positives means I'm going to get a negative answer. 2 times 2 is 4, 2 times 2 is 4, and 4 times 4 is 16. So the answer here is negative 16. Whereas in the parentheses, if the negative's with it, then you have to be a little bit careful. Negative 2 times negative 2 is positive 4. Negative 2 times negative 2 is positive 4. And positive 4 times positive 4 is positive 16. Notice these two answers are not the same, and you have to be really careful about it. I like the first one. The first one just tells me the answer is going to be negative. The second one students like better because they can see the negative 4 times and they like that better. I'm not necessarily sure why. Notice the next two are kind of similar, but they have a cube instead of a square. We're going to interpret it the same way. So the first one with the negative out in front does not mean the negative is included on the cube. It's almost as if we're taking the opposite of 2 cubed, or negative 1 times 2 times 2 times 2. 2 times 2 times 2 is 8, and 8 times negative 1 is negative 8. Whereas the last one here means negative 2 times itself 3 times. So negative 2 times negative 2 is positive 4, and 4 times negative 2 is negative 8. So notice this one. These two are the same answer. They're both negative, whereas the first two, they were not the same answer. One was negative, one was positive. So you just have to be really careful that you're interpreting the exponents to only the thing right behind it. If the parentheses is right behind it, you include the whole parentheses. If the 2 is right behind it, and not the negative, if just the 2, then you only cube the 2, then slap the negative on. So we're going to be using exponents while we learn about order of operations. That's one of the steps. The order of operations has 4 steps. A lot of times people think there's 6 steps, and I'll tell you at the end why, but really you need to understand that there's only 4 steps. Step 1 is parentheses. For parentheses step, I want you to perform all operations with any parentheses symbols, starting with the innermost set of parentheses. So notice I have a parentheses here and I have a bracket. It also could look like a brace, like squiggles, okay? Most of the time we use the braces for set notation, but it possibly could be another set of parentheses if you needed another shape, okay? Step 2 is exponents. Perform all operations from left to right with any exponents. Then you go back to the beginning and do all of the multiply and divide. Again, from left to right. And the last step is do any add or subtract. Again, you perform all your operations from left to right. Now, we have an easy way of remembering this called Pemdas. P stands for parentheses, E exponents, then multiply and divide, and add and subtract. A lot of students will memorize Pemdas and think there are 6 steps to Pemdas. There are not, because multiply and divide belong in the same step going left to right. Add and subtract go in the same step left to right. So instead of writing Pemdas like most of the other teachers, P-E-M-D-A-S, horizontally, I still use Pemdas, but I just write P, E, then M and D on top of each other, and then A and S on top of each other, and then I have this line on top reminding you that you're going to go left to right. Okay. One way of remembering Pemdas is please excuse my dear Aunt Sally. I'm sure there's lots of other phrases you could make up, but got to know your Pemdas. So let's do some practice.